All right, at Dunbar Middle School, we have a variety of lasers. What you see in front of you is a 1-watt handheld laser. I'm not sure if it's blue or green off the top of my head. I think it's blue. We teach a variety of things with lasers. The light that comes out of the laser is coherent light, and coherent light is basically when all the wavelengths match up. When you're looking at light coming from a ceiling tower, or any kind of like incandescent light that you see up there, that's called incoherent light, and the wavelengths are spread out and the energy is spread out likewise. But with a laser, you have coherent light, and all the wavelengths match up into a single line. So just like up there, those light bulbs are, I don't know, 100 watts plus, lots of energy, but the energy is spread out, where this is just 1 watt and the energy is focused into a narrow beam, which allows you to transfer that energy over a long distance. I'm going to turn the laser on now. Give me a second, and hold on 1 second, let me get this going. Okay, the laser is now on. Hold on, let me set it on high. And so there we go, it's on. And you can't really see it, or at least it's hard to see the beam because of basically interference, wave interference from the lights above it. So you can't see the beam, but it is there. And as I place a white balloon in front of it, it doesn't pop because white reflects. White reflects that energy, and all that energy is being reflected back. Now that's important. That's an important concept that we can use to teach students with. That the more glaciers that we have on the Earth's surface, the more energy is reflected by the sun. Because the energy that's coming out of this laser is a form of radiation. Just like the sun emits radiation, so does this laser. And if it hits a white surface, it's reflected back into outer space. That's called latent radiation or latent heat. Where if you have darker colors on the Earth's surface, it is absorbed. So let's pretend all the ice caps go away through global warming. Now you have darker colored objects, so like blue water and so forth. That's going to absorb the energy from the sun. So what I'm going to do is I'm going to put a darker color onto this balloon, and this is what you would show students that come to Dunbar for a field trip. You place a darker color on the balloon, and you can draw a face here. Try to entertain them as much as possible. You could ask them, who do you want to draw, and they might say their teacher or something like that, or a famous person they might know or whatever. So I'm going to draw a little person here, and I'm going to have like a crying face, and I'm like, why is he crying? They're like, I don't know. I said, because he's getting ready to be blown up. The laser's going to do some terrible things to him. So I'm going to take the balloon now and place the there it goes. I placed the dark colored part of the balloon right in front of the laser, and it blew up. So we can also teach energy transfer. You have chemical energy in the laser, which is transferred to light energy, which is transferred to heat energy, or so forth. Another thing that we could do is place a match in front of it, and you see here that the match has a green surface, so that energy is going to be absorbed by the match, and when it's absorbed, it can catch on fire. So as much as you get the kids to interact, the better. We want the kids to interact with this. They can even hold the match. This is their field trip. We want them to experience this, and yeah, very cool. Another thing that we can even teach is that light has to have an surface to reflect upon to be able to see it. We can't see this light in front of us, but when I blow the match out, the smoke is going to go into the air, and it will allow the light to reflect off of it, which we can see the laser better. So here's an example. And there it goes. Not very good, but maybe we could do 2 or 3 and they 2 or 3 matches, and they'll be able to see it because there'll be a lot of smoke there. Can you stick your hand in front of it? Yeah, you don't leave it there though, because then it can cause some burning and so forth. All right. Other properties we could teach is refraction of light, but I don't have that set up to demonstrate that. We won't have that set up tomorrow for or any kind of field trip that I've done lately to show that. Other things we can do, we can get a black balloon, a red balloon, a blue balloon, ask them do they think it will pop, and create the experiment and see if it works. And that's part of the scientific investigation. You come up with the hypothesis, would a blue balloon pop when exposed to the laser? That's the question. You form a hypothesis, see what they think, see what they believe, and then create the test. So at least we can get 2 or 3 parts of the scientific method down that way. All right, thank you for watching. If you have any questions, see me as soon as possible.